Hi everyone, this is Samir Juri speaking, and thanks Mandy to handing over to me. Now, after Mandy gave you the introduction about our presentation for today, I would like to give you a little bit more insights about thermal management for batteries. And in order to give you that, I will start by giving you somehow the battery trends that we found in the industry. So there are definitely different battery trends that we've seen. First of all the OEMs want to conform to the global safety regulation and standards. Everybody wants to lower the cost of the electrical vehicles, which are still considered to be too expensive at the moment. There's a trend as well to conform to a cell-to-pack designs. One which is extremely important, especially for us in terms of thermal management, is the higher pack energy density. So basically having more energy within a compactor space, improving the C-rate charging, and finally have some design which is ready for an automation of the pack batteries. So what does that mean? This means that in terms of thermal management, there's a lot of solutions that can be used there in order to help to fulfill these trends. Why thermal management? Because as you can then understand the trends, you can understand that heat dissipation is definitely something which will be required. High thermal conductivity then is a key to be successful there. It's not only about the heat dissipation and high thermal conductivity, it's about the electrical insulation as well, because here we deal with very high powers or very high voltage. Compression and harness of thermal material can as well be addressed there with thermal management materials. And finally, all the thermal management materials have very low hot gases. So that's the reasons why thermal management materials for batteries can somehow help to be in the trends, I would say. There's a last information which I wanted to give before I move to the next slide. You have to know that electrical vehicles are said to be effective. That's quite right, but there's still 25% of the energy which is produced by the vehicles, which is transformed into heat. So this heat has to be removed as well. And 25%, that's quite, I would say, a huge number. And there's definitely need for thermal management in electrical vehicles, and especially in batteries. So now I would like to show you some, actually 3 examples that illustrates the importance of thermal management in electrical vehicles. And I will start by something which is, I would say, well known. If you're in the winter time or in the summertime, it's possible that, well, the range of your battery is reduced by something around 18%. And it's just because the cell resistance will be somehow changed in the winter time by the cold temperatures. And that's the reason why you will have less autonomy. There's definitely some possibilities to address this problem, maybe not to solve it completely, but at least to minimize it. And the solution is to use here a proper thermal management strategy. Another, I would say, typical issue or typical trends that can be somehow assisted by proper thermal management is with the charging. You can see that nobody really wants to wait for ages when it charges his car as a loading. That's quite normal. And you can see that even on the marketplace at the moment, there are some great differences. If I take, for example, one of these 5 cars, I will take the one on the right side. The one on the right side is a 5-seat car, which is affordable, has a capacity of 64 kilowatts hours. And you can, I would say, charge up to 80% of the capacity of this car within 60 minutes. This means that you have some energy peaks at about 60 kilowatts. Now, if I take a nice 5-seat SUV, luxury, the same year of construction like the car which I've just presented, then you have only 30 minutes in terms of loading, but for 95 kilowatt hours in terms of capacity. And now, if I make the calculations in terms of peak energy, we have up to 200 kilowatts. which starts to be a huge number. And in that case, this means that, remember the 25% of energy transferred into heat. This means that you will have to deal with high heat dissipation, and on top of that, probably as well with high electrical insulation. So that's typically, again, one of the cases where the thermal management can play a role and make the difference between two different kinds of electrical vehicle. The last example, which I wanted to make you aware of, is the battery cooling and temperature control. So I will take here the example of the lithium-ion battery life cycle. You can decide to have absolutely no cooling in your batteries. That's fine, you can do that. However, if you do so, the lifetime of your battery will be 4 years. You can decide to use air conduction, so air cooling, to do that. If you do so, you will then have a better lifetime of 3 years compared to that. And if you use conduction, so liquid cooling, which is actually the most efficient way of cooling down a battery, then you will still extend the lifetime of 2 years. So again, this really proves that depending on what you're going, so which thermal management strategy you're going to go for, you will have very different results in your car and in the performance of the car. So now let's focus a little bit on the batteries and in the thermal management application that you can find in the batteries. So actually, we've defined 5 of them. First of all, maybe to explain that from, I would say, a high level, here, the challenge that you will have in the battery packs is that you will create a lot of energy, then a lot of heat in a very confined space, and you need to transfer this heat to the outside environment. So this means that here you can already from the right-go set imagine that thermal management is a key to success there. So what do you have to be aware of? You have to be aware of that in your battery pack, none of the parts have to be a bottleneck. Yeah? And this means that, for example, parts like adhesives can be already a key for the success, and you need to consider some thermal management with the adhesives or with any bonding elements in your batteries. Same thing with the cables. So that's what I told you 2 slides ago. You have very high power within short times, creating a lot of energy. So here again, you will need to have some thermal management on these coatings, as on the cables. There are some coatings. The cells is the heart of the batteries. They produce the most energy there. So here again, you will need to transmit all the heat to the outside environment, probably by using some pads between the cells. Once this heat, I would say, reached the battery housings, then the heat will be, also will have to be transferred to the outside environment. This means that the battery housing will have to have some thermal management. And finally, we've seen a lot of batteries design where there's a cooling plate which has to be somehow linked to these cells. This cooling plate is supposed to cool down all the cells. And here again, you will need some thermal management so that you ensure a good cooling contact actually between the cells and the cooling plate. So here, as you can see, there's a lot of different challenges in battery packs in terms of thermal management. Battery is not the only area in a car where thermal management is important. That's a general trend. In antennas, for example, you will definitely find some challenges with thermal management. Same thing with the electronics, same thing with the headlights, and of course, same thing in the motors, where again, high energy has to be somehow converted into heat and then has to be transferred to the on-site environment.